We had a little fun at the Linquist house last night.
What did you do?
Not what I did, what Ziva did.
What did you do?
Well, let's just say there's one less opossum in the world.
Oh, like did it like walk in from like eating pasta?
Well, no. Well, no. No.
That would've been bad.
They treat a raccoon up about 30 feet up a tree. That was Ziva's job. And Gibbs treat a possum. And my wife got the dogs in the house after they barked at the things forever. And all I say to my, anybody have like a really obnoxious barking dog in the neighborhood?
Oh,
Yes,
mine.
there's-
Mine can be pretty bad too. And all I say to myself is, oh God, the neighbors must hate me. They must despise me. So if they start with the barking, get them in the house. Well, when Ziva pinned down the possum made the mistake of coming down out of the tree. And Ziva likes to dig. So she dug some holes. And we have a front yard and a backyard fence, obviously. But underneath the fence, there are two, you know what railroad ties are?
Yeah.
They're pretty big, like wide and thick. We have two of those. And Ziva dug the hole, and she also dug under the railroad ties a little bit. And it's all behind a rhododendron tree, so it's like really tight, you really can't get in there. The possum went down in the hole. And it was under the railroad ties, so Ziva couldn't get in there and get to it for an hour. This high-pitched, excited barking, Ziva's going on, and on. Driving, it must be driving the neighbors crazy, and all I'm doing is saying, oh my God, I gotta get her out of there. I couldn't pull her out. She would not move. She wasn't going anywhere. She wanted that possum with the worst way. So then, I had to get the possum out of there, otherwise the neighbors wouldn't have been able to get any sleep last night. So I take a hose, and I shoot the hose up the hole. The possum pokes his head out, and it was all over so fast.
Oh my god.
It was just bite,
Oh my god.
pick up, and she shook her head so fast that all you heard was the possum's spine go crack.
Ew. Oh my god.
And that was that.
The end.
She must have shook the head of this thing 7 or 8 times in a second. And it was a dead possum. And that was it.
Did she eat it?
No, she just killed it. Then she smacked it in the head a few times to make sure it was really dead. So, yeah, well, not everybody did. So that was the end of that. There's actually a video, if you go on a video on YouTube and you look up Central Asian Shepherd Dog versus Wolves, there's a video from the National Geographic of like 1960 with 2 of these dogs, and they put like National Geographic music on there, like Bach and Beethoven. Dun, 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 dun. It's like Superman coming through. So the wolves go in and kill a couple of sheep. Right? And the sheep are so stupid, they just stand there, they don't even move. So the wolves come in, they grab one, they kill it, they come in, they grab another, there's 2 or 3 wolves there. And then up comes the dog running up the hill in the snow, bounding through the snow, and that's where the dun 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 dun. And then the dog comes in and fights the wolf.
I can
That's
see it.
awesome.
Within 30 seconds, they killed 2 wolves.
Oh my
Oh, they were vicious. It was, and they do the same thing. They got the wolf down, and they pick it up by the throat, and they shake violently, and it's over. It's just done. Just nothing left of it. So I feel like posting a YouTube video of the moment and saying, burglars beware. Come in the house, it's over. There's just no hope. Abandon hope, all ye who enter therein, or something like that, whatever that saying is. All right, let's go through these 3 particular equations after we talk about number 2. What's the property? How do you know it's the commutative property? Because it kind of looks associated with the 2 packages there.
Because it's still grouped together, they just move them over.
That's right. They're moving them, which means they're switching them, and they're still grouped together. It's still 3 plus 1 and 3 plus 1. I've just moved the 8 from the end to the beginning. How many people had that was an example of the commutative property? All right, looks like a little more than half. Be very careful. Listen, that is a classic, absolutely classic Regents exam question. They love to throw that curveball at you. So be prepared. If you put down that you thought that that was associative, I get it, I understand. I probably did the same thing at your age. But you have to look a little deeper. It would be associative if it said this. That would be associative. Because now, we're changing who's in the parentheses. First, the one is hanging out with or being grouped with the 3. Second, the one is being grouped with the 8. In the problem that was actually written, it's not like that. It's just we're moving where the 8 and the 3 plus 1 are. All right, so I take a look at letter A. This is a very typical question. It's danger, danger, danger. What kind of 4 is that?
A positive.
Good, so I have to do -4 and -4, and I get -12 equals -3n. Then I divide by -3. The big mistake that you see people make here is people forget that this 3n is negative, and they'll just kind of lose the negative sign there, and they'll just make it 3n, and then they'll divide by 3. That is not a mistake that you want to be making, especially after we've seen this many, many, many times. Okay, letter B. We have letters on one side, numbers on the other. So, is this a same side situation or an opposite side situation?
Opposite side.
Opposite side.
situation.
So I want to get where I have my letters on the same side and my numbers on the opposite side. 5a's minus 2a's is 3a's, minus 9 is 26. I add 9, I add 9. I get 3a is equal to 35. I divide by 3. And now we get to something that I've had happen pretty much every day, or almost every day. What do you do with an answer like 35 over 3?
Leave it as a fraction.
Exactly, leave it. Do not convert to a decimal. Now, did anybody on their paper write 11.7?
Nope.
You're wrong. Did anybody write 11.6 repeating?
Nope.
Had you done that, you would be right.
What?
If you convert to a decimal properly, you get credit for it.
Oh.
The problem is a lot of people like to round off, minor.
Don't judge.
So what happens is, because of the quick rounding off in their head, they end up getting it wrong. But I assure you that I understand the language of fractions completely. So 35 over 3 is a good way to go. You could have written 11 2/3. That's also good if you felt you wanted to go that far, but 35 over 3 would be pretty good too. Yes?
If you just converted it to a decimal, you would have got it right, so why don't we just convert it?
Because I'm telling you, a lot of people get it wrong when they just convert it.
Oh.
If let's say there's 21 people in the class, which is what I think there are, 15 of them will write it as a fraction, all 15 will get it correct. 5 of them will write it as a decimal, 3 of them will get it wrong. It happens all the time. It has happened for 30 years. It's going to continue to happen. I wish it wouldn't happen, but it does. And I think even your calculators, like some people will go so far as to copy what it says on your calculator. If you did this on your calculator, it would say 11.66666666667. And kids will write that down. It's wrong. Because the calculator automatically rounds off at the last place.
So
Why?
it would just be 666.
Yes, it would continue, so you have to write the little line on the top. All right, so here we go, distributing. 3x plus 12 plus x minus 2 is equal to 20. Let's get all our x's together since they're on the same side. 4x, 12 and negative 2 is plus 10 equals 20. Minus the 10, here we go again. 4x is equal to 10, divide by 4. X is, now, 10 over 4 is fine. 5 over 2 is fine. 2.5 is fine. This is a case where if kids do it on this one, they get it right because most of the time they get it right. Because it doesn't have a repeating decimal to it. You know what I see some kids right here? 2.1.
What?
There's 1 left over after you divide the 2 into the 5. Or if they did the original one, they write 2.2. And I just shake my head and I go, why? Just leave it as a fraction. Or 2.5. Okay? Yes?
Okay, I got the third one. I got to 3x plus 12 plus x minus 2 equals 20. And then I just got confused after that.
Well, the minute you look at a problem, you always want to ask yourself, is it same side first? And if it's the same side, you want to do the same operation. So as soon as you see that you have a 3x and an x on the same side, you want to combine them and make it a 4x. And as soon as you see the 12 and negative 2, you want to combine and make it a 10. Now that's actually a great question to ask because we're now going to go into today's lesson. and it's the perfect segue. What are we supposed to learn today, guys?
How to identify examples of.
Oh, actually, your teacher screwed up. That's not what you're supposed to do. You're supposed to learn how to combine like terms. So, combining like terms.
Make me sound.
Now, probably the best way I know of to combine like terms is to think about it in terms of buckets. So there's a couple of buckets. Anybody here ever seen the movie Gran Torino?
No. What's it rated?
No one has ever seen the movie Gran Torino? Wasn't that a great movie? It is a great classic movie. It's about a time in America. We've softened things down now. My grandfather was one of the hardest men I've ever met in my life. He's probably the hardest man I've ever met in my life. These were the men who stormed the beaches at Normandy. They were men who survived the Great Depression. If you will, they were a man's man back in the day. This man showed no love. None. Now, I know he loved me, and I know he loved his family. But his idea of love was tough love. And I happen to respect tough love a lot. I think there's a lot to be said for tough love. But the way he showed his love is through doing everything he could for you, but he had a certain expectation. And man, you did what he said, when he said, how he said. Even at 96 years old, he was tough as nails. In the movie Gran Torino, wasn't a guy like that? Now, my grandfather had a Gran Torino, the same exact year, 73, and he gave me the 73 Gran Torino. He is a very tough human being. And he taught me how to fix the windows in my house. He taught me how to replace windows. When he did that, he came over with a series of buckets. And in the buckets, he would have little tools. So something you'd have to do is some spackle work. You would need to do some rough work, which is inside the window work, or inside the wall work. And then there was finish work. So he had a bucket for each kind of thing. And you could take the tools out, you could use the tools and everything else, but he went home and he wanted me to return the tools. Now, when you've got a hard-edged man like this guy, and you go to return his tools to him, those tools better be in the right bucket. Could you imagine in that movie if you gave Clint Eastwood the tools in the wrong bucket? It would not be a very pretty sight. So, you learned everything went in its bucket. Or as perhaps you've learned this saying from your father or your grandfather or your parents, a place for everything and what? Everything in its place? You've never heard of that?
No.
Oh, man, you have heard that?
No.
All right, well,
Cricket.
all right. When I was a kid, it was drilled into our head. A place for everything, everything in its place. You have to put things in the proper bucket. And that's what went on with this problem. It's literally how to do this question. See, I have a bucket here for my A's. This is like my rough work bucket. And a bucket for my B's. This is like my finish work bucket. And I have to make sure the right tools go in each bucket. You see, if I went to my grandfather and I put something back in the wrong bucket, when he wanted to do some rough work, he just grabs the bucket labeled rough work. He just grabbed the bucket, all the things he needed was in there. If it wasn't in there, it wasn't put back in the right place, and the whole problem broke down. And that's exactly what happens in a math question. See, this is 4 A's. I'm going to put my A's in this bucket. What kind of 3 B's is this? Positive. So I'm going to put my 3B here. What kind of A is this?
Negative 1A.
Negative A. And then there is a positive 2B here. Now just tell me what's in the buckets. What's 4 A's and a negative A? 3 A's. And what's 3 B's and 2 B's?
5B.
Now, is it a positive 5B or is it a negative 5B?
Positive 5A.
So just write down that it's a positive 5B. That's my answer. 3A plus 5B.
Oh, I get that.
That's all. It is easy. It's all you got to do. And Molly, on that question, it said equal something. Just cover up the equals, do the buckets, and then go back to the equals, and you'll get it right. All right, you try the next one. Go ahead.
I know, right?
See what you come up with.
I need to join these buckets. Yeah.
Now, let's be clear. It doesn't matter if you put the buckets, if you put the letters in the one on the left or the one on the right. But for practical purposes, we normally put the letters on the left. So negative 4x would go here. Positive 3 would go over here. Positive x and negative 8. You need to be careful about the signs in front of each thing. Remember, you always peek in front to see what it is. What's negative 4x is plus x?
Negative 3.
Negative 3x. And what's positive 3 and negative 8? Negative 5. Now, if you had this answer, these two answers are exactly equal. All right, so you're not wrong. But I will tell you that there's this thing called standard polynomial order. And it means the x's go first, and in fact the highest exponent goes first, and then you work your way down in exponential order until we get to the last one. All right, try the next one, and you can do it drawing the buckets, or maybe try to do it without drawing the buckets. Okay? If you're going to try it without the buckets, work on getting all of your A's together, then all of your B's together, and all of your C's together. What do you think, guys?
What? Oh, you said
I have 3 A's, and I have a negative 2A, so far I have 1 A, agreed?
it. Yeah.
And I have another negative 2 A's, so that makes negative A. I have a 2B and a negative 5B, that's negative 3B. And then I have a negative C that's all by itself in its own bucket, if you will. Does that make sense? Okay, now let's take a look at number 4. And I want to make sure I get number 4 done before the end of the period. What do you notice is a little different about number 4?
There are exponents.
There are exponents, but we don't change a thing. We have to understand that an x squared, an x, and a number are as different from each other as a's, b's, and c's are. So, what I'm going to do, if you will, is have a bucket for my x squareds, a bucket for my x's, and a bucket for my numbers. 3x squared plus 5x minus 2. Now, where does the x squared go? Does it go on the left, in the middle, or on the right? Guys, where's the x squared go? Left, center, or right? Minor? Left. Yeah, absolutely. I put it with the other x squareds. Now, what about the negative 7x? Where's that go? In the middle. And where's the negative 9 go? On the end. So now let's look together. What's 3x squareds and another x squared? Guys, what's 3x squareds and another x squared? 4x squareds. Good. Now, what's positive 5x's and negative 7x's? Negative 2x. And what's a negative 2 and a negative 9?
Negative 11.
Negative 11. Sweet. Did you do this last year?
No.
No, I think you were supposed to. Listen, it's the same lesson tomorrow, okay? Place for everything in its place. We will work it out tomorrow. Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci, smile a lot, ciao. Arrivederci, adios amigos y amigas. Cheerio. What was that?
What time's the last one?
5:30 to 7:30.